Good evening and welcome to all the attendees. I am Professor Amit Sethi from Electrical Engineering in IIT Bombay, and it's my pleasure to host this talk today, to moderate this talk. As you know, our guest Rohit Ghosh, Mr. Rohit Ghosh, is an alumnus of IIT Bombay, and he plays a key role in a startup that is working in medical imaging. So this is Rohit. Hello, Rohit. How are you?
Hi, Professor Sethi. I'm all good. How are you?
Good, good. Thank you. Thank you for joining us. So I share certain things with Rohit. I also I also work in medical images, as some of you might already know, and this is quite an exciting and interdisciplinary area of work. I never thought I'll have to study biology after class 10. Like all of you, I also prepared for JEE and then went for engineering. But here I am now. I can diagnose at least one type of cancer myself, and I'm sure Rohit would have his own stories to tell. I am quite sure you will find his journey to be quite interesting. Let me give a brief introduction. He's a founding member of Qure.ai, which is an offshoot of Fractal Analytics, an AI-based medical imaging company. So Rohit is responsible for business development and strategy within particular geographies. He has previously worked as an AI scientist and is involved with the R&D in the computer vision area. He has more than 15 publications, including one in Lancet. That's amazing. And before Cure, he was a data scientist for ListUp, which was a P2P buy and sell platform, and a freelance data scientist for Data Science Labs, which is a New York-based edtech MOOC provider startup company. Rohit has also worked with the Japanese investment bank, Nomura. So, without much further delay, let's hear it from Rohit. Let's hear about his journey. Let's hear about what he does at Cure. All right, over to you, Rohit.
Thank you. Thanks a lot, Professor Sethi, for that nice introduction. Yes, there's a lot of things that I completely connected to in the biology space. So yeah, I have a small presentation. Probably it's easier. I thought that might be have a small presentation to just talk you through. So yeah, I'll just share my screen. Just let me know if you're able to see my screen right now.
Yes, we can see it now.
Okay, great. So I've just kept, I just got some few slides from here and there. And the idea is primarily, I think when Adesh and I had a chat, the idea was primarily to talk about two parts that specifically which is firstly is what's AI in medical imaging, what it looks like, what we do at Cure. And also personally, the journey that I have had since college, right? The last 5 years, how it sort of played out. So I want to sort of decouple those two things. So there's part which is a personal journey, and also then there's a part of what Cure does and what's specifically we have been looking at in AI in medical imaging, how that works out. So that's primarily it. Want to sort of look at around 30-35 minutes of probably conversation. But in case anyone wants to interrupt, absolutely, and specifically Professor Sethi, if you have any questions in the middle, just feel free to jump in. And after that, we obviously want to take as much questions as possible. That's the idea. So without further ado, I think wanted to start from start. So life at college. So this is a picture of my fourth year final valedictory function, VALFI, right, at college. And so college, I think 2010 to 2014 is when I was there at Insti. And primarily in terms of how life looked there, it was obviously the most enjoyable moments, four most enjoyable years of life that I definitely cherish. At Hostel 4, mostly it was definitely fun. Very less of ACADS that I would actually be, ACADS was obviously there, but then apart from that, there was a bunch of things I was into, in debate and all of that. So there was a lot of those things. I think in terms of now looking back, what sort of played out is obviously there was 1 year stint as at the entrepreneurship cell that was definitely key, because what happened after that was I got this whole thing about trying to look at businesses and trying to understand how to sort of contribute value, what's the problem they're facing, and doing that kind of a thing. And I remember I still used to go out after third year. I would go out and help this. So there were different food vendor stalls So me and my another batchmate Niven, so we used to go out there. We used to talk to these guys. We figured actually like a business consulting agreement with few folks there. I started doing similar things for some other startups that I came in touch during the e-cell stint. So yeah, those are some of the things that sort of shaped up that. And the plan was primarily actually just after college, most like everyone. It was a plan for an MBA. Coming from Meta, there was, yeah, I mean, core was definitely not that I was planning for. And so that was primarily very, I would say, very normal how it was, right? But then some things didn't work out. Got a placement offer at an investment bank. And obviously, the major thing that I was looking out at the investment bank was primarily more in terms of. So then they came, obviously, the presentation and the pre-placement talks that you normally have at college was more around the fancy maths that you get to do, and awesome stuff that I'm primarily looking forward. I was looking forward to doing. But in reality, it's probably not that. I mean, when you end up in an investment bank, you realize the maths and all that you wanted to do versus what you actually get to do is really very different. So that was something that was, yeah, it was a short, fun, but I guess not so engaging stint at for almost 9 months, I guess. I mean, within the first 6 months, actually, I had pretty much decided to make up my mind that this was something I'm definitely not going to do. I mean, obviously the excitement was definitely missing. That was something I had figured out within the first 6 months. So yeah, I had taken. Then I thought I'll probably give CAT again. I'll figure that that's probably the first thing. But while I was preparing for CAT, I figured that um, I actually don't want to probably do that whole route that I was thinking. And the more and more it was coming out that I wanted to do something on my own. I wanted to sort of do things that are on the edge, and that was obviously the thing that was I had figured out in college third year. And then and then I said that. So this was a brilliant advice that I received back then, which was that if you don't take the risk at that point in life, right, which was around 5 years back, just 1 year after college, then it's probably not going to ever work out, right? I mean, you're not going to have get a chance to take that risk, or it's going to be a bit more expensive. And that sort of resonated very well with me, I would say. And then what I did was I said, and I had already been planning. So Nivedan was still there, and he was in Dubai, and we started planning around what we could do, after I left my job. So we started planning on a bunch of ideas, tried working on a logistics-based startup. Almost 3-4 months down the line, I realized. So there was obviously 2015 was that time in around that entire ecosystem around in Bombay for white specifically, where everyone was trying to do very different things. A lot of my batchmates were, and that was a very engaging time period. But what I realized was I did not want to do on an aggregation app or something like that. It was just not making sense. I mean, I wanted to do the core maths, the thing that I so really loved, right? And aggregation and building something which was operationalizing that was not really actually interesting. And more importantly, I realized I did not have the feel for it. I mean, I cannot sustain doing that. So that was the most important thing. So I think 3-4 months after we started doing that, I said I'm not really, and both of us really decided that we don't really enjoy this as much. So that also again stopped, I guess, somewhere around. So I left job around, I guess, July of 2015. Um, then this is primarily around October or November of 2015 that this also did not work out. Now, unfortunately, what had happened was all the savings that I had was primarily used up in the startup founding and all of that. So now I'm at a November 2015. That's the photo that you have from me, which is almost similar to actually how I look right now. But it was very difficult in a sense that obviously I'd run out of savings, and it was a slightly low point in the sense that I was not sure where it goes from here onwards. But yeah, one thing was very clear, that I wanted to pick up machine learning, and I'm not machine learning. I was very keen on picking up something which is hardcore maths and stats related. I was not sure what it was, and that's when I actually remember talking to a friend. And while we were doing these pitches for the startup, some VC basically gave me the idea that do natural language processing. I'm sure that's a fancy word someone picked up from some Silicon Valley thing, and they just said that do NLP and you can do much better on some idea here. And I was like, what really is this NLP? I mean, I just picked that word up and I started googling the thing out. Uh, and yeah, that's how I came to machine learning, and that's primarily. So I had done some courses while going back if I look back at the IIT journey, I had some courses in computer science, which I had either optionals or taken up as electives, but nearly nothing on specifically machine learning, right? So that was definitely not there. So most of the courses were primarily the ones that I had taken were around data structure algorithm kind of a thing. So that's the most thing that one thing that I realized is obviously I do not have any kind of, I mean, I have an understanding of how to sort of code things up, but not specifically the theory behind machine learning. So one obviously easy thing, which 2015, obviously everyone was in that mood. So I picked up Coursera. I started actually learning machine learning and that famous Andrew Yang course. But I realized that that's not giving me the enough theoretical understanding that I actually want to do. So this is a very interesting story. So I actually mailed Professor Saket at IIT again back, and I mailed him. I said, I'm the alumni from 2014 batch, and I am someone who wants to learn a bit more of machine learning in theory. I mean, I'm very like, there's a lot of content outside, but it's not really bordering much on theory. And I was under the impression, based on my earlier conversations, that he was the one who was doing the machine learning course for that semester. So this was 2016 spring semester I'm talking about at Insti. And then he said, no, it was Professor Ganesh who was taking that course at that time. And then I again mailed him. I had not known him much. And I asked him, can I just attend your lectures? I'll just come down for and I attend probably just like the entire lecture period. And obviously I was unemployed, I had really nothing to do. It was not also very tough call for me, right? I mean, I actually had all the time in the world to actually go and pick things up. So that was it. So that was interesting. So he said, absolutely, feel free to come down. I mean, although he was a bit busy, so he said, I would not be able to help out of office hours, but absolutely happy to, coming over to the class and sitting there and, understanding whatever doubts you have. I'm absolutely happy to resolve that. So that's some of the I'm genuinely thankful to a lot of people in the journey. And that's definitely Professor Ganesh, definitely is very helpful in that part of the journey. And that happened, that was 2016. And simultaneously, because I run out of savings, so I basically figured out I have to somehow get something going, right? So that's how Kaggle obviously was something I was doing separately. I was trying to apply all of the learnings. And I started also getting a lot of work on freelance projects on Upwork and some of that. That's how I came up in touch with the EdTech platform in New York, and I started working for them. And also simultaneously, ListUp was another startup that was starting out in the Hawaii Valley, as you would call it, that point of time. And they were looking at P2P listing. And they were primarily looking at objects that you would put up on the website. And you detect using AI what is the object and put out automatic description of the object based on the image. So I started the image, I would say, data science work. So this is all primarily happening in the first half of 2016. I'm simultaneously going to college, back to college almost, to pick up ML. I'm starting to apply on a bunch of things. And this is January to February 2016, or almost start of March. And that's how, so that was all happening. And then Fractal, which is a parent company of Qure at that point of time. So they had approached me for something else completely different, actually not related to Qure. And that's how I got to meet Prashant, who's the CEO of Qure. And at that point of time, it was not really called Qure. It was called AI Innovation Lab within Fractal. And that was, I guess, it, right? I mean, so I met Prashant, and then we had a really long conversations around what exactly was on his mind. And that's how, I guess, there was, I think, 4 or 5 of us back then, the part of the founding team, we got started. And so this happened in March of 2016, right? And Qure was, I think, the official founding date was somewhere around July of 2016. So that's how the entire journey into AI and Qure happened, which was after a lot of ups and downs and all of that. Now that is primarily journey till Qure started. Now within Qure also, it's a very interesting journey, right? So now as you understand from my career, obviously there's machine learning that I fairly probably got a good hold of, but deep learning definitely not, right? So the phase 1 of that journey was about just learning and learning at a extremely neck break speed, where I'm trying to pick up a lot of. So I started working on machine learning things that we were already doing with Yale University at that point of time. which was around cardiac failure of patients and some of those organ donations and how you can make that process a lot more interesting. So initially, just to give an idea, I mean, when we started up here, the idea was more around AI for better healthcare, I would say, right? AI, how you can use for better healthcare. It was not really specific to deep learning at that point of time. So we were exploring everything, starting from I was looking at something, someone else was looking into genomics related projects. So yeah, that was a fairly mix and match of things where we were trying to do back in 2016, start of 2016. March, April, I would say. And it was not really fixed. And then obviously some of those publications started happening, which obviously gave us a lot of credibility as well as I would say confidence. I mean, for me, it was a lot of confidence that, okay, there's actually some quality work that we are probably able to do, which is getting out there. And then I would say that was around, probably June of 2016, somewhere around that we started figuring out, okay, probably AI for radiology and AI specifically for medical imaging makes a lot of sense. So I had started working on this lung nodule open data set that was just open sourced, I guess, very quickly right then and there. And that and plus a few other projects gave us two ideas. One is obviously medical imaging, the value that you can generate, and the value is actually perceived much better on the other end as opposed to some of the other work that we were doing in, cardiac or organ transplant kind of things. So medical imaging, the value is there, and also in terms of computer vision as a space, at that point of time, I understood, and all of the, I would say, collected understanding was that computer vision is a lot more advanced in terms of what you are able to achieve. I mean, semantic segmentation or some of the other techniques were just above. I mean, right now coming up to the point that we thought that it's actually way more accurate, I would say, not really accurate, but robust. I mean, more robust, and that can actually be something that can be used to get more better results than opposed to other forms of machine learning. So that was one of the things. Now, the biggest challenge actually that happened, which was 2016, is that I had no clue. As Professor Sethi mentioned, I have no clue about medical images and, for that matter, anatomy of body and all of this, right? And this was a huge learning challenge once again, which is that now I had to start picking up two things on the side. Right? Now I'm trying to understand a bit more about medical images, the body parts, the anatomies. I remember reading up almost, there's a book that I had downloaded actually. In fact, all of us had downloaded the book. It's a fairly large book on anatomy, going through that, understanding anatomy, medicine as such, right? And biology that I had, exactly, I had also not completely thought I will ever read all of that after 10. So started doing all of that, and simultaneously also deep learning. Now, deep learning also at that point of time was fairly in an interesting space. I mean, obviously it was not like so. I mean, today obviously everything is a lot more easier. The codes are publicly available. There's a GitHub repo. At that point of time, I remember we had. So this is a paper snapshot that I've attached to UNet. So UNet was actually the first ever, I would say, the paper I read back then. And Theano was the most important, I would say, the most common coding language. And all of these current things like TensorFlow, Torch, and none of those things actually existed back then. So it was Theano and then Lasagna and some of that. And it was a very weird space also. I mean, there was a lot of things happening at the same point of time. There was like replicating some of that stuff was also a challenge. I'm sure it's a lot of challenge still now, but it was a genuinely big challenge at that point of time, right? So yeah, that was the first phase one, I would say, that was learning and picking up on the medicine piece of things actively, as well as picking up on deep, because deep learning is obviously something that was evolving. So ResNet started happening then. So some of those landmark papers also started coming in, and it was more of a daily thing that you started getting into the habit of reading papers, reading the most recent papers on the blog. So I absolutely love that phase, because now it was finally into a zone that I was really loving, right? Because it's on the edge, you're learning about maths/statistics in a very active way, and there's a lot of story, there's how it's evolving. So that was something we started enjoying. Now the second phase which started happening was, I guess, somewhere again towards the end of 2016, now towards starting of 2017, is now we had almost got a good exposure. Everything was in place. We had been working on a bunch of data sets. So now we started working on real life problems outside the open source data sets, on real life data, real life challenges. So specifically, I started working on the HCT software that we now have. So it was a AI for non-contrast CT head interpretation. And while that started happening, so that was the building stuff, which was actually now getting more interesting in it, because now you're on real life problems. You are actually targeted on detecting a specific kind of a problem. And I actually today I actually have so much understanding. Again, I completely understand the point Professor Sethi mentioned, which is I have actually so much understanding that I can actually look at a head CT and tell you what's the major abnormalities, if there's anything missing there or not. So yeah, so some of that thing, those journeys, also very specialized learning happened, and also at the same point of time, deep learning itself was evolving, right? So I mean, and not I just only, I'm the entire R&D team, which was actually fairly limited at that point of time. So all of us started with taking a lot of active interest in how we can build a community also around it. So we started putting things out on Short Science, um, on the Qure blog that we have, GitHub. I remember I would still, those days, FRCNN and some of those things had come around, and there was a lot of people who were having issues replicating that. And I remember during one, I guess, Diwali of 2017, and I was not able to go home. And I've said, I want to give people what they can on Diwali. And I started resolving everyone's issues on GitHub, because I had actually worked very heavily on object detection at that point. And I went to GitHub, I opened all the issues. I said, okay, you know what, because I have to resolve all of these things, I actually fairly understood what the major things were, right? It was fairly convoluted code base. So I started resolving all those issues. So yeah, phase 2 was more interesting in the terms of, you started working on problems, and you also started, there's a lot of learning that you suddenly gained because of the active involvement, which I now also try to figure out a way to sort of broadcast that to a open community or teach that also. And I started teaching at Grey Atom, which is a data science teaching academy based out of Mumbai again. So I started taking courses there. That also sort of gave me a lot more confidence. Although I was teaching primarily the machine learning part of it, which was a bit to remove the active scene on computer vision side, but all of that sort of gave me that more clarity. I mean, once you start teaching people, once you start telling people actually about how things are done, that gives you a lot more internal clarity also. I mean, that's always true, right? You start teaching. So that started happening. And not only Grey Atom, I started taking also some guest lectures at NMIMS. So that, I guess that was fairly late also. That was probably 2019. But this was, I think, 2017 to 2018 was the phase 2, which was Qure getting into the journey. And there's a phase 3, which is what right now I'm part of. And I'll probably come to that slightly bit later. But before I do that, I just wanted to probably give you an idea of what Qure does, right? So what is that we are trying to do? What is that we have done till now? So, I mean, at Qure, we have been primarily working on a AI for medical imaging solution. And there are 2 major flagship products that we have built over the last 4 years, I guess. The first one is AI for automated chest X-ray interpretation. So it's a software which can look at a chest X-ray, it can identify all major abnormalities from the chest X-ray. And the other one is the AI for non-contrast head CT interpretation. It can look at a CT, it can identify all the critical things. All of these are like the CE certified, the FDA. Very recently, we became the first ever Indian company to receive FDA certification for the head CT software. So yes, that's been primarily, I guess, the 2 most important things that we have been building in terms of hardcore, productization and, in user base across the world. Apart from that, we have 3 more products. But yeah, primarily it's a chest X-ray, medical, and the head CT interpretation. And today we have been deployed almost, I guess, 17,000, 20 plus countries. I guess it's 22 or 21 countries. And COVID obviously saw a huge uptake in that. We saw with COVID, there was a lot of deployments that we anyways did around 40, 45 sites. But today, I guess there are all in all, there are probably 110 sites globally that we have been able to deploy the products, somewhere around 17,000 to 18,000 scans that we were processing for just specifically for on a daily basis, right? So that's something that fortunately, we have been able to scale that, the story that we have based out of India, how we could actually go out and do that at the rest. The different parts of the world has been slightly interesting, and also, a moment of, we have been really proud that we could do that, right? Based out of India, being able to compete with some of the top I mean, today, if you look at probably the AI in medical imaging companies globally, definitely we would be part of the top 5 AI in medical imaging companies globally, right? So to be based out of India and to be able to impact that on a global scale has been something that, I mean, we generally think that's something we have a good story that we have been able to craft out. In terms of scientific base, this is primarily, as I said, I mean, we have been extremely focused from day one to make sure that we have publications in medical journals, and also not only any journal but also the high impact ones, right? So Lancet obviously was one of my, I would guess, one of the very landmark papers in my journey so far. So Lancet obviously is one of the most prestigious medical journals globally, and Lancet's first ever AI in medical imaging publication. So they had not published anything on AI in medical imaging till then. So this was October of 2018. Lancet's first ever AI in medical imaging publication came out, and that was the work we had done at Qure on HCT. And apart from that, very recently we have got publications in Nature Scientific where we have been compared against 5 other AI companies, and they found Qure to be the best performing AI company. So in terms of product quality, that's a huge achievement to be able to compare against other 5 AI companies and to show that the system that we have built is actually the best performing in terms of accuracy, I mean, AUCs and other metrics. And yeah, so we have also got patents for both the chest X-ray as well as the HCT software. So this is in terms of what Qure primarily looks like. So the 2 products, you have got deployments on the basis. But the question obviously is that, so that's what the software is about, but what is the problem that we are able to solve it here, right? So that's the question that I wanted to probably give you a walkthrough about. So I'll talk about one of the use cases of the chest X-ray software, primarily in India. So in India, TB is the biggest killer. I mean, even despite COVID and what COVID has been able to do to India, the truth still remains TB is the biggest serial killer in India, right? Today, I think as of last year, there were 10 million cases of TB reported just in one single year. And out of that, so there's an estimated cases of 10 million, okay, right? That's not a confirmed number. There were 6 million diagnosed cases, but the estimate by WHO says that this is almost a 4 million to 5 million undiagnosed cases that exist, right? And those are some of the maps show some of the high TB burden districts. And just to give you an idea of TB, right? I mean, so today, if you're looking at the deaths in India and number of cases that has been affected because of COVID, it's even not close to 1 million, right? We are probably talking about some 100,000 cases probably at the best, or somewhere around 100,000 to 500. I don't have the exact numbers, but so 10 million cases of tuberculosis patients which would actually are reported. And of that, there's a significant fatality rate of also TB in the country, because obviously the healthcare infrastructure is not as developed in the country. There's a lot of resources. So in fact, this video I have is from one of the centers in, it's in Kota, so where we had deployed the product almost 2 years back. And this guy, I mean, just to give you an idea of what the video is about, and I'll play the videos. So the guy is normally based out of very remote area in Kota. Now they have, for their TB detects, for the TB screening test, they have to come all the way 500 kilometers from their local, from the area where they're based out of, which is a fairly remote area, to the district hospital to get their TB test done. Now, as a person who's probably on a daily wage earning basis, right? So this is a huge challenge for them to take out a day completely for coming there. And then also, if you don't get the results, you're like asked normally, because there's a huge amount of people who normally turn up daily for this kind of testing, because the number of centers are limited, right? So at one center, you have multiple people coming in. So for them, this is a big challenge if they're also, firstly, you take out your day's job, and then also you come there and then you're losing your, you're not sure when the results will be out. So just listen from him what his actual challenge is.
डॉक्टर साहब से इलाज के लिए, और डॉक्टर साहब जब दिखवा लेते हैं तो जांच लिखते हैं, तो जांच कोई कहते हैं कि 5 दिन बाद मिलेगा, कोई कहते हैं कि 10 दिन बाद मिलेगा, 5 दिन 10 दिन बाद भी आते हैं, एक जांच मिलता है और जांच फिर कहते हैं कि 10 दिन बाद आए। इस तरीका से हम लोग को बहुत बड़ा परेशानी बढ़ जाती है। हम लोग 100-200 कमाने वाले हैं, और यहाँ खर्च आने जाने में 500 रुपया पड़ता है, लोग लाएंगे कहाँ?
So this is a very real problem of TB in India, right? So you do not have you just do not have enough means to support the immense amount of cases that is happening, and a lot of that problem. So as you said, so in TB what you normally have is you have a first point of diagnosis, normally the chest x-ray, and if the chest x-ray normally looks suspicious, then you normally send it for a molecules a microbiological test, which is a sputum test or a array test. So that's a normal workflow across, I guess, most parts of Southeast Asia and Africa. So if you're looking at that, and that's why if you remember in the video, the guy talks about कि पहला जांच करने को बुलाते हैं और फिर 5-10 दिन बाद फिर वापस से जांच के लिए वापस आते. So that the first जांच is basically to get the results of the chest X-ray, and then the second जांच is for the microbiological test for confirmation, right? And the big delay that you see is because of a huge lack of radiologists per se in India, as opposed to for the same number of population. For 100,000 population, we have almost 10 times lower radiologists as opposed to US what we have in India. So in India, it's just a big challenge, right? And that's the exact point where we have been able to solve using AI. So this is what currently happens right now. So after we deployed the software in this particular, and not only this, right? So there are almost multiple sites in Southeast Asia. So the protocol has now changed from in all these places is that you take the X-ray in a mobile van, or you have an X-ray machine in a mobile van that goes out to very remote areas. It's offline, completely offline setup, so there's no internet connectivity that is required. So you go and screen patients in these very remote areas, and as soon as and because they're portable X-ray machines that are fitted in the vans, so you get the patient, you take their X-ray, the AI instantaneously screens whether it's a TB suspicious or not under 2 minutes, right? So while the patient is there, they have just they start pulling on their shirt for before they want to get out. You already have the results of their TB screening, yes or no, right then and there. So if the TB is suspicious for that patient, then you collect their sputum then and there, and within 4 to 5 hours, you start your medication. I mean, you would have your diagnosis whether it's TB likely or not, and your medication starts, right? So this entire workflow suddenly changes a diagnosis time that was almost 3 weeks. At the least it was around 10 days, 10 to 12 days. At the best it was, at the most it was probably 3 weeks, 3 to 4 weeks. So that suddenly has reduced to 4 to 5 hours. And this is real stories across, and not just India, right? I mean, multiple parts of the world where we have shown that this is huge amount of efficacy. And the second thing that also has happened is now we have done enough studies to show that the AI is also actually better than human readers in picking up cases of TB, because TB a lot of times shows up in a very subtle way that physicians in the first read are not normally able to pick up. So we have almost have a 25% higher sensitivity of the AI system to pick up that TB as opposed to a human reader. So which also means that the same number of X's you're actually able to identify more. And WHO has, for example, set out India a target of 250,000 cases per, 250 cases per 100,000. Yes. That's the incidence that is expected. Now, today we are identifying somewhere around 180 to 190 cases per 100,000. So there's a definite lack of 70 more cases that we are missing out. And that's also one of the challenges that we are able to overcome, because we are able to detect it at an earlier stage and much better than human readers, right? The other story that I have on the HCT software, right, which is primarily something that is changing the story of healthcare in this remote center in Kerala, not just here in multiple parts of the world, but the stories from India obviously are more fascinating. So this is a trauma center. This is again in Kerala, remote slightly. So what happens is radiologists are normally there from 10 a.m. in the morning to around 1 p.m. or 2 p.m. in the afternoon. Right after that, there's no other radiologist at that site. Now, what happens then is anytime there's a critical patient who comes in with a road accident or something, if they are admitted after 2 p.m., either there is someone non-specialist who's looking at that and getting some diagnosis and next steps done, or they are waiting for the next day altogether morning if they're not able to make that up. Imagine how dangerous that is, right? So you have the diagnosis being either done non-specialist or gets done next day altogether after 8 hours. So what we have done there is, interestingly, is that we deployed the AI, which the HCT software, which looks at the cases. It can pick up if there's something critical as soon as the scan is done. And what we found is, obviously, unlike US or UK, where we deploy and radiologists have the facility to report from home. In India, obviously, that's not the kind of internet connectivities we have. So we figured we cannot do that whole remote reporting that we do in other parts of the world. And we came up with a very interesting solution where we started putting all the radiologists of that hospital in a WhatsApp kind of a group. And then as soon as there's a critical patient that we identify, we notify directly on the WhatsApp group. Right? And it's a very interesting innovation, not innovation, but it's a very interesting workflow integration that we did there, right? And we made the cases on the, with the, obviously all the patients' data is de-anonymized, but we say that there's a critical thing that you need to look at right now. And then they can chat on the group, they get started. So this is a very interesting story of how the HCT software is also able to help in remote places where you do not have radiologists altogether, right? So now is a quick slide of, so Adesh asked me if I can also quickly talk about what's AI. And I don't know, probably I'll just breeze through it. Absolutely happy to come back later. I think it's much better, obviously, to learn. This is almost a year semester course, right? I'm trying to just finish it in 2 minutes. But let's say, the question I get asked normally is that what's AI, right? So the question, so if you normally go for a movie, right, and then you want to take a decision whether you want to go for the movie or not, right? So there are different factors that you take into consideration, right? If it's a movie review, so that's something that is universal, I guess, across all people. And then for each of those factors, you have a personal preference, right? So which could be different from person to person. And then how you decide for the movies, you just take a weighted average of your preference for that corresponding factor. You multiply that, add that, and if the scores say vary from minus 200 to minus 300 to plus 300, so 0 is the middle point. So you say if it's greater than 0, you go for a movie, you don't go. I'm just talking about a very simplistic case of how you would want to go for a movie, right, depending on various factors. And what AI is primarily about is that instead of like making that decision, you have a bunch of decisions of some person. Let's say this is my decisions for different movies, right? So the different parameters, and then my score for each of those cases, whether I want to go for that movie. And based on that, the job of the AI system is to primarily figure out whether what is my preference for each of these, right? And that happens primarily in 3 steps. So like a greedy algorithm, if you have to guess what are my preference for each of these things, you would start off with a random guess. You give a prediction, you see if that prediction is wrong or not. If that obviously the prediction, it's because you start off with a random guess, that's going to be wrong. So you may have some error, and you then start making adjustment to that preference number that you started off with to make sure the prediction comes to actual reference. And you do that for one movie, and then you go for the another movie, and then you start doing that, right? So this is primarily the idea of AI systems as a whole. I just made a very breezy explanation, but I'm absolutely happy to come back if you need some more help. But that's about AI. And now what it does is primarily about chest X-rays. Is primarily you would have images, so medical images when you do AI. So you have got chest X-rays, then you have got reports for those X-rays, so whether it's a TB case or not, right? And this could be based on a radiologist who have reported that case, or it could be a gene expert, which is a microbiological test. And each medical image is basically like a pixel-wise representation, right? So each of those pixels is like in the past example, as I mentioned, movie review and all of those things are parameters. So in the medical imaging problem, each of those pixels are your different inputs. And based on those inputs, you start making a decision like the same thing, right? You start off with a random weights, and then you start predicting whether it's TB or not, and then you make adjustment to the weights until the point the AI system starts performing brilliantly well for all the medical images. So in essence, this is primarily about it, right? So it's a very simple, medical image is just another different way where you are looking at, instead of different ML factors, you're looking at pixel-wise representations normally. And that's primarily about, I guess, what's Qure, what's AI in medical imaging. And finally, just wanted to take out Adesh again. We had a chat and we discussed it's probably some things that if I could share some learnings about the journey so far, specifically from if you're someone who is looking to start or looking to build AI in healthcare, medical imaging company. I'm not sure AI in healthcare might be a different game, but if you're looking to build AI in medical imaging, what are some of the advice that I can share, right? So the first one is trust is important in healthcare, right? It's very important one of the ways to build trust is primarily for us has been, been open sourcing, at least contributing to the community to the extent possible, and most importantly, getting peer-reviewed publications out on a continuous basis. That has been something that has worked very important. But trust is very important in healthcare, right? If you start doing anything where you're like, and that happens a lot of times in healthcare is also that you start, because it's a high stake industry. So I have seen also people like, do a lot of, data manipulations and all of that when you quote accuracies or some of that. And specifically in AI, that's a very interesting thing that happens. So once someone figures that out, right, and then it's very difficult for any company for that matter to come back from there. So trust is very important. You have to be absolutely open about what work you're doing and explain to the world as much as you can. Obviously, not without giving out the IP. So that is the first important thing. The second thing is, and the next of the things are primarily around, so you build an AI system, right? And that's not easy. That's definitely not easy. But building an AI system is just not about it. And there are a few more things that are also important. And some of those things are probably more important than building the AI software itself. And I just wanted to touch down on some of those points. The first one is operationalizing. So which means that there's a DICOM protocol which normally happens between communication between medical devices, and there's how you present the reports, right? How you integrate with machines, right? And that workflow of how actually the processing happens and how the all of that looks like. So building the product around it, right? So the AI piece is just the software code, which is the machine learning and the deep learning piece, right? Now actually making that into a product that works robustly well across all places, that itself is a bigger journey, right? And that's something we realized once we had the algorithms, that it takes a lot of effort to actually make that real life and make that work in real life. There's a lot of challenges in operations that you realize. So that is important. The third piece is that data acquisition is very important. As an AI company, you have to definitely think about, because AI primarily runs on the amount of data that you're training it on, right? So you have to be sure that and for example, the chest X software today outperforms all other AI software as per the most recent study. Now, why did that happen? A good part of that reason is it's trained on 2.4 billion chest X-rays, as opposed to the other AI software which have been trained on a smaller data, right? So data is important, and if you're building AI in healthcare, medical imaging specifically, then you have to definitely think about where your data is going to come around, because that's what is going to make definitely good. Obviously, good algorithms have a role, but good data and better data definitely has a bigger role to play in that accuracy game. And more importantly, I guess selling is also as important as building. So building is definitely important, it's critical, but what we have realized is also that to actually for people to use it and pay for the software, you also have to think a lot deeper into how the healthcare infrastructure works, how payments work, and insurance providers work, and to understand where you actually provide the value is also very important, right? And that's why we have seen the same chest software has got like 6 different use cases based on geographies, based on systems. And it's a very different, the same software with the same capabilities have a very different meaning and application across the world. So that's something we have to keep in mind, because healthcare is very convoluted in that sense. So building is awesome. Building is something we obviously, as some people, all of us primarily from IIT, it's very easy to actually, not easy, but it's definitely something we can do quickly. But then to also take it to market and think about how you actually place it is also something we found was very critical. And finally, last but not the least point is that regulatory part is also as important as building product. So you have to think, when you build that's very critical in healthcare. So if you build softwares, you have to also think about how to get the regulatory approvals for them in place. So it's a CE marking or a FDAs and all of that. And that's something which is very critical for your final success, because at the end of the day, you are a medical device, you have got patients live involved. If you are software which is just a software without the rest of the things not being looked at, and what I normally feel is that a lot of times people have this outlook that you can build a regulatory part later on. I would suggest that probably if you're looking at building an AI for medical imaging AI software company, it's good idea. Obviously not at the first day, but definitely somewhere down the line it should be something that you should start looking into how you can do that, right? Because it's normally tedious processes, takes time, but it's worth the effort, because at the end of the day, that's what in the end would actually differentiate you versus anyone. Because if you're someone who's already CE certified, that makes a lot more your as a company, the trust is a lot more better established. So definitely that's something that plays out in the long run. And that's about it. I guess the final thing is, obviously, personally for me, phase 3 of Qure journey has started out from last 1.5 years, which is more about letting the word out about Qure. So primarily looking into how to take the word out of what we have been doing and talk to different people, and understanding that selling part of the journey, right? So which is taking the software to different parts of the world, understanding how we can help them. Because obviously, as someone who has built the software, I have a very good clarity of what the software does as compared to say any other else. So it's much easier for me to converse with people across the world. So that was, on the left is my 2019 map of the different places. I almost spent like the entire year on the flights, I guess. But thankfully 2020 has been kind to me. I don't need to do that anymore. I'm doing all of that on virtual calls. But yeah, so for personally, it's been a very different journey altogether for me, because now the time has come for to look at integrating and exploring all those different use cases, getting more people to use the software. And yeah, that's primarily about it. I guess 2019 has been a very different journey. So is 2020. And yeah, so now it's a different aspect personally for me. And absolutely happy to stay connected with everyone. I did a very short session. I mean, obviously, there are a lot of other things I could share, but I would absolutely love to stay connected with everyone. And I think that's primarily about it. I guess.
Hello, Rohit. Looks like we lost him. So, till we get Rohit back, there is a poll that is being floated for all the participants. You have about 5 minutes to fill that up. So, please, all of you, please fill that poll. So, you see the poll question on your screen right now.
I
Rohit, are you back?
Yeah, I am there.
Okay. All right. I just
Are you able to hear me?
Yeah, we can hear you. We can't see you, but we can hear you. Yes.
Okay, so sorry. I guess my yeah.
Okay, great. So I just told everyone about the poll. Hello.
So I just realized my internet went off in the middle. So I was not sure if everyone got the entire part of the conversation.
No, so it was only for the last 1 minute or so that we couldn't hear you. Before that, it was all fine.
Okay.
Yeah.
Okay,
So
fair enough. So
did you have any concluding remarks? You had just started talking about how to keep in touch.
Yeah, that's about it. I guess there's nothing about it more
great,
than that.
great.
That's
all right.
Yeah.
So students are filling out that poll, the attendees. So let me start taking some questions. Thanks a lot, Rohit. This was very interesting, very fascinating. There are lots of questions from the audience. So two questions I will summarize quickly. How did you choose your initial team members, and what kind of people did you have on your team?
So ideally, the initial founding team consisted of 5 of us. So all 3 of us primarily from IIT Bombay. Uh, there was Prashant, who was he obviously had his PhD, and George, so he's obviously fairly senior to us. So he's the one who's CEO of Qure, and so that was primarily him, and then obviously Dr. Pooja Rao. So I think so. Dr. Pooja Rao is primarily the one who comes with the clinical background and who has the understanding of the medicine part of things, and she was also incidentally working on um, data science at that point of time. So I think that's how it came together. I think so. If you look at it, primarily it was mostly her from the clinical side of things, and rest of us primarily from the computer science kind of a background. So that's how the founding team was. I guess that's primarily about it. I mean, in terms of how that played out, obviously, because all of us were, and all 5 of us were, I think 6 of us were that first initial period, I think all of us are very focused on just reading papers and building stuff, right? At that point of time, there was nothing else we were doing. So just that. So yeah, I think that kind of a team at least worked for us. I'm not sure
Great.
how that worked for everyone else.
Great. So that also answers another questions. Do you have doctors and medical researchers on your team? So kind of answers that you started working with a doctor. I think that's pretty critical. It's also one thing that I realized. So when I started working in medical imaging, my student participated in some competition, did well, and then I realized no, there is insights are missing. We are treating it as we would treat ImageNet, right? As if we know what a cat and a dog is. That's not true, right? We need to get deeper into it. We need to understand what is the difference between tumor and hyperplasia. When is the basal membrane? I'm talking in terms of pathology, but I'm sure in radiology there are similar insights that you must have gotten by working with
Right.
doctors and so forth, right? All right, great. So, an interesting fact actually,
Exactly.
Prashant
For
and I.
example,
Yeah, go ahead. Go ahead. Go ahead, Rohit.
I was saying that how we have medical images, same thing. I mean, we realized, for example, one thing was when you have an injury, you normally have a diametrically opposite point. You also have an injury. How you look for fractures. So some of those things are, very critical in a medical imaging kind of a setup, and that's something I got to learn from radiologists. At that initial journey, I remember I would call up radiologists, almost listen to them guiding us that through. So that's very critical. I mean, some people we already have on the team, and there are a lot of people who are advisors to us right now, through whom we actually understand that as well.
Great. Now, I was saying, so you mentioned Prashant. Prashant and I we both went to IIT Delhi. We were 1 year apart. But we never met there in IIT Delhi. I met him only after coming to
Ah,
Mumbai. We ran into some conferences, AI conferences together. So that's how I know Prashant. So there's a question. You have explored a lot
interesting.
on the go and try to figure many paths. Seeing your peers have a plan and they stuck to it, did you feel pressurized to figure it out? If so, how did you deal with it?
No, I mean, in reality, I was looking back at the journey today and I figured that there was not really a pressure. I mean, obviously, I had run out of savings and there was not really a way. I was not sure what it would, but it's not really like I was under a pressure of such. I mean, I actually had that freedom suddenly that I was so looking for last like 1.5, 2 years that suddenly I had the time to actually explore things that I had, sort of kept on the side burner. So definitely pressure was the last thing actually on mind. It was more of like finally I had that whole corporate thing was finally off, and now I had the chance to really think deeply about what I really want to do. And so that I think that's a very deeply satisfying, gratifying place, a very powerful place also, because then you don't have anything to lose, right? Then you just start thinking on what you want to really do and not really follow a career path.
That's amazing. I mean, there's a story of a journal who wanted to attack a particular location. They went there by ship, and then he burnt his ship so that there's no plan B to retreat. It kind of sounds like that. So very fascinating. Okay, there's a
Yeah,
question: is accessing medical
absolutely,
info?
exactly.
Yeah, go ahead. Uh, shall-
Sorry, go
uh,
ahead.
yeah, is accessing medical information in bulk for training models difficult because of the sensitive and private nature of medical records?
Oh yes, absolutely. It is. It is difficult, and that's why you need to think about how you do that and how you have your data acquisition mechanism in place. Because that is something in India. Obviously, I would say it's difficult, but at the same time, probably slight bit easier than say what you would do in other parts of the world. But having said that, it is still something that you cannot just go ahead and. I mean, even if you do, you might be in spot for a trouble later on. So it's better to think about how you collect it at bulk. It's needed in bulk. You can do it, but you have to think really thoroughly about it.
Okay. How did you connect with different hospitals and clients to deploy your product?
Oh, that's primarily the first set of users were the most important. So those were the people we knew personally, or we had built that relationship over time. And we told them that this is something we had done. So the first initial deployment, I guess, within India was Chankaria centers in Bombay. We knew Dr. Chankaria through some other relationships. So Prashant knew him very well at that point. And then outside India, our first deployment was, I guess, in Philippines, where there's a lot of TB incidents. Uh, so the first set of users are the people whom you probably would personally know. You know what their problem is, and actually, in a way, I also would think that the first set of users were the one who actually dictated the journey of the product. So I mean, to a good extent, at least in the first place, because they are the ones who kept on telling, you know what, this is a problem, that's a problem. Why don't you fix that? So. Yeah, so you normally those are personal relationships that you would have, or through someone you would get to do, and once they start you liking the product, they tell to more people. That's how I think the second bunch of users come in.
Great. So is this also how you get your data to train the algorithms? So you started with those first few connects, and they gave you the data.
It's a very interesting story how we started doing the data. The most initial thing that we did, right, and very early phases of just X-ray journey, I would say, we actually started scraping online for data. So we had, like, there are a lot of radiology articles. There's a lot of Radiopedia, a bunch of things that's there online. So that was I guess the most the starting point in terms of how we did it. But obviously, yes, second phase of that data is obviously not reliable, neither it's sustainable that way. So, and that's a very small amount. So then we started reaching out to the first level of users. Some of them did agree to help us with the data. Some were not very helpful. So yeah, I guess those, obviously some of those people were definitely helpful. Not all of them, I would say.
Okay.
But yeah, getting a data for training needs you need to be completely in agreement with the person, right? So that you're using that data for training.
Great. There's a question: to whom do you sell your products and services? Let me refine it. So there is a doctor, and then there is the business person on top of the doctor, for whom the doctor is working, and so forth. So how does that selling process work? What do you sell to, at which level, and so forth?
Right. So this is actually very interesting question. So there are, like, different people we sell to. So it's not like just a hospital we sell. In fact, hospital is the in priority or the top, not even probably the top three people that we want to sell to. The first, most, I guess, critical people, most, I guess, the people we have been able to sell successfully are the people in public health. So public health normally means that primarily for TB and other related ailments, right? So in this case, it's normally the TB program manager of a TB program setup. So normally TB programs are these NGOs which are funded by different aiding company, global aids, and those are the people whom the TB program manager is the one who's actually taking a decision on what kind of softwares, how you do the entire scaling program, right? So there are different program managers in different parts. So that's in terms of public health. That's primarily it. In other parts of the world, the ministries of health we work across, right? So in ministries of health, normally again the head of radiology is the one who's normally the one who's taking a decision on what to use and what not. So very rarely I've seen someone within the business aspect. So in actually all these aspects, it's normally always a clinician that you ideally sell to, because the clinician is the one who understands the value of the product. The business person is just looking at what the value is generating, but that they will only come to if they're absolutely happy with the clinician saying that the product is good to go, right? If the clinician or the head of radiology says that they don't trust the product, there's no way no one's going to use that product. So that's I think those are the important people. And also we sell a lot to teleradiology companies or companies who are doing radiology at bulk of volumes. So yeah, so those are different people, and hospitals are probably much after that, probably come after that.
Okay. I want to do a time check. This is quite interesting. So we have run out of the hour. Are you okay for a few more minutes? And Adesh, also want to check with you, like, can we go a few minutes over?
Absolutely.
Oh, there are a few questions. I guess like we can take up maybe one or two more.
Okay. So one question, quite interesting follow-up. How hard is it to get the doctors to trust the diagnosis made by a machine?
It is very difficult. It is because obviously for them, for people perceive that we are actually replacing them. So normally they tend to take us with a bit of a pinch of salt. But at the same time, I think what we have realized is that it's actually those places where they don't have enough access to radiologists, is the place where we are able to contribute most. So if they already have something where the systems are broken, in those cases, they just don't have any other ways to look at it, right? So those are the people. Hello?
Yeah. We can hear you.
Yeah. So yeah, those are I guess, the places where I think you see the maximum impact in terms of where people don't actually have the infrastructure, right? If they're doing 5 weeks to days to delay.
So let me ask a question of my own. So for TB, it's quite an interesting societal problem, right? I mean that we should be solving, and I'm very happy to see that Cure is at the forefront of taking AI to solve the TB issue. Uh, what does the financial model look like? Because a lot of people that you would be serving are probably those who cannot afford much, right? So is it a volumes game, or is it more of a public funding game? How does it work?
So in all of these places, you're primarily looking at charging. You do not normally never ever charge obviously people who are using the product, right? So the end user, the patient, is not whom you charge. So the charging is primarily mostly for people who are the program, who are TV programs, who are running those TV programs, right? So, and that is primarily through a public health funding, right? So there are organizations like Bill and Melinda Gates Foundation or a Global Fund, or their USAID, and all of those kind of people who are actually funding those programs. So they already receive a funding amount to look at, like say around a fixed number of screening that they need to do. And once they have that funding, obviously then it's easy to show how using AI they can deliver better care. So I guess in terms of funding, we never almost never ever look at the end user, right? Because these are programs which are public health funded.
Great. Let's change gears a bit. Arjun is asking, I'm a first year student and I want to take up a career in deep learning and AI. How should I go about it? Should I pursue online courses or do projects related to AI or internships or something else you would recommend?
So I would say definitely not make the mistake that I did, which was I was in IIT and I did not really bother to do the classes at that point of time, and I came back 2 years later to do those classes. But in terms of, firstly, if you're in Bombay, definitely in Insti, then you should definitely take up your electives accordingly. If you're not in IIT, or if you're not able to do computer science courses for some reason in whichever college you are, then the second thing I would suggest is just do a lot of hands-on project. Right? First, do Kaggle. Kaggles are good because they are nice and neat data. It's good to get started, but then you should start working on real-life data problems, right? So there are a lot of this freelance data science portals where you can get working on real problems. Real problem is what I think makes a difference, and most importantly, it's not really knowing the most advanced algorithm that actually, I guess, counts. It's actually about how you solve a problem. That's what I have figured. So if you are able to convince someone that you can solve real life problems, and you don't need to tell what is a support vector machine, or learn that by heart, but you should be able to tell me, if you're looking at a problem, how you are solving it. I think that capability is very, very important.
Okay. This is an interesting question. How accurate are your flagship products? Can you give a sense for how accurate are human experts versus how accurate are your products?
So if you just talk about TB, as I mentioned, so this was a study that was conducted by Stop TB Partnership, which is a Geneva-based WHO-funded TB eradication program. So they looked at 23,000 patients from Bangladesh, and they compared Cure along with 5 other AI softwares, 4 other AI softwares, and also human readers from all different experience categories. So senior readers versus junior readers. And what they found was primarily that the AI systems, all the 5 AI systems, actually perform better than human readers. So the human readers had an AUC of somewhere around 0.81, I guess. The worst performing AI software, which was had the AUC around 0.82. Obviously, then from there onwards. So I guess Cure had an AUC of 0.92, I guess. So somewhere around there. So 0.92. So in terms of what we have shown is that human readers don't normally necessarily, specifically for chest X-ray, there's a lot of inter-operator variability.
Okay, so I guess for the readers, I want to clarify that how AI gets better than human readers is because you train against the gold standard of gene expert test, right? As opposed to the radiologist interpretation. Is that correct?
Exactly.
Okay. All right. We can take one or two more questions. One question is that since there are frequent changes in the AI technology, new advances, how do you update and adapt your software to keep up with these new changes?
So obviously, as a someone which are regulatory, so our regulatory guidelines dictate a major part of it, which is that every time there's obviously the AI system is learning on the go. There's an update that is happening, but FDA or CE guidelines mandate that every time there's a the weights of the model, for example, change. That's a different model in itself. So you have to get a new CE approval and all of that. So in terms of approval mechanism, there's a proper mechanism and protocol in way to sort of update your models and get approval for them on a going on basis. And apart from that, I guess in terms of tech as such, we are we are obviously looking at what next we can build. And idea is there are obviously a lot of disruptions which are happening, but what we are primarily focusing on what the healthcare challenges that you have exist in parts of the world, like for example India, Southeast Asia, where the systems are actually broken and needs a lot of there's actually a lot of opportunity there versus say other parts of the world where the healthcare system is not as broken. So in terms of next chapter or where we look at, I think that's primarily what we are looking at, making healthcare a lot more accessible and affordable, specifically in these parts of the world where it's not.
Okay, thank you. Let's take just one last question. So, what is next for medtech AI disruption, or what is the next chapter for Qure.ai? I mean, is it like radiology, more radiology, pathology, genomics? What are you guys looking at, and what do you think where the world is going?
So I think what generally people are looking at is more of what we have been realizing is that the idea of getting healthcare at home. So today, for any healthcare needs, you need to go to a hospital to get your scans done and do all of that, which is obviously a tedious process. That's not how it should be. And I guess a lot of healthcare organizations, not just Cure, is primarily focusing on how to make that healthcare available at home and take that to a broader audience. Right. Today, a lot of our presence is primarily for hospitals or radiology clients, right, as I said, ministries of health, but not really for end users. So I guess in terms of where we are looking at next, I guess a lot of that focus would be on taking how we can build AI system to make that accessibility problem solved, right, where how we can take healthcare at home somewhere not really at home, but somewhere at least easier, where you do not have as much equipments or infrastructure to do, right, remote areas, how can they make their healthcare systems better? So mostly on radiology side, but yeah, how not on products that can make that accessibility problem solved.
Okay, sounds good. I'm sorry I couldn't take all the questions. We have to close now. But this was a very fascinating talk. Thanks a lot, Rohit, for sparing this time. It was quite useful, I'm sure, not just for me, not just for the students, but also for me. I want to say that. Okay, thanks a lot. I hope you wouldn't mind if some students reach
Thank you.
out to you for further questions personally.
Absolutely. Feel free to everyone. Just feel free to reach out to me on LinkedIn, Twitter. I'm absolutely trying to take out that time right now to get back to people. I'm more than happy to answer everyone individually as much as I can.
Okay, thanks a lot. Okay, take care.
Okay,
Thanks
thank
a lot,
you,
also,
Professor,
Professor
and
Sethi,
thank
for
you, Rohit.
moderating that.
Yes, Rohit, please
Yeah,
continue.
thanks, Adesh. Thanks a lot, and thanks, Professor.
Yeah.
Now, I was just saying thanks a lot, Professor Sethi, for just conducting the session. I really have been looking up to. I mentioned that also to Adesh that while we were building up, I have been genuinely, and the entire R&D team has been looking up to your work as well. So I'm absolutely aware of what you have been doing, and you're leading that space within India. So Shubham and some of your, I mean, everyone, I guess, from the founding team, right? We definitely really love the work you're doing. So thanks a lot for that, and thanks a lot for conducting the session. It was really just pleasure, I think, to at least meet you virtually. We had connected on WhatsApp earlier, but definitely it's a real pleasure. I would definitely love to work with you later on. Absolutely.
Sure. Thank you. Thank you. Adesh, you were saying something?
Oh, okay. I was just saying, thank you, Professor Sethi, for moderating this talk, and thank you, Rohit. Um, Everyone, thanks for attending. Please leave feedback. We'd love to hear it.